Hey everyone, this is Conrad from Sloppy Joe Pirates, and today we're going to be talking about Incognito 4.0 CTF. It was a event hosted by Equinox, which appears to be some sort of like hacker fest programming competition conference sort of thing hosted out in India. Not too familiar with it, but they have a very snazzy website, and it looks like a cool event, but I'm just not familiar. But they hosted a CTF with a couple of challenges. It was definitely more of a beginner-focused CTF. Like we're not doing any heap exploits, and the crypto stuff is more of like character-by-character stream cipher. But overall, it was pretty fun. I only focused on reversing crypto, pyjail, and pwn. I took a look at some of these other categories. They were more of the scavenger hunting challenges. Nothing wrong with that. It's just I kind of like the more traditional sort of security-focused challenges. And with that, let's get started. The first challenge is TheOnlyJail. And we're just given a netcat port, no description. So if we try to connect to it, this challenge has been down all day for me. I solved it originally and I took a screenshot, so I think I'm just going to have to cover the screenshot, but normally you would just netcat and it would give you the pyjail prompt. But thankfully I did take a screenshot when I first solved it. Usually I just use these for my notes, but I guess we're just going to do a review of this. Oh, it did connect. Sweet. Let's see. Yeah, it's working. Okay, cool. So we connect to the jail, and right off the bat, I just tried a bunch of different characters to see which characters were restricted. Eventually, I found that we're allowed to use parentheses and no other special characters. So normally on one of these, I do like import OS, but we're not allowed to use the underscores. So I tried just doing import OS, and surprisingly, that worked. Then I try os.system. And let's do an ls. Very slow. All right, I'm just going to work off the screenshot. So this is the screenshot. Normally I only use this for cannot fork. Yeah, I think there's just something wrong with the challenge server. It hasn't been working since I first solved it. But anyways, this is the screenshot of when I originally solved it the first time. So like I said, I tried ls just to make sure we're in Python. I tried and then I did an import os to see if we're allowed to just get an easy win. It said we're not allowed to use underscore. And so from that point, I just tried all the different symbols to see what we're allowed to use. I noticed the only symbol I could find was parentheses, and everything else was forbidden. So then I tried an import os, and surprisingly that worked. And even more surprisingly, os.system.ls worked. So we have shell on the box already. From this point, I'm trying to figure out where the flag is. So I did os.system, ls home CTF, and it said we're not allowed to use slashes, but that's easy to work around. So os.system, ls plus, first I tried character 47, which is just the slash character, to see if I could filter on that. But I forgot that they don't allow plus signs. So then in a different terminal, I did a base64, you just do base64.b64 encode, and I passed it this string, ls home CTF, and it returned this text here, the bhmgl text, and so then I can just pass it and do a base64 decode into OS system, and there's no special characters, we're just using parentheses, and I got the contents, so the flag's just flag.text, and then from there I do os.system. This time I did cat home CTF flag.text, base64 encode that, wrap it here, and then I just do a quick base64 decode, and there was the flag. So not too hard of a challenge. It's a bummer the jail is down right now, otherwise I'd show it live, but yeah, that was it. Quick challenge. The first crypto challenge is ancient. It says we found an ancient image, but we're unable to figure out what it is. Can you help me out? And we're given a challenge.png file. What's interesting about this challenge.png file is you can't open it. So it seems to be corrupted or something, but we can do a strings on it. So challenge.ping. We look through it, nothing too exciting. We will see a created with GIMP, a text comment, an IHDR, and some sort of profile. If we do exif tool maybe on the challenge.ping, we'll see there's some sort of file format error. So at this point, I loaded it into Hexfiend. I saw that this IHDR, I think that's only in ping formats. So what I did was I loaded it in Hexfiend to see if maybe it's just missing the start a couple of bytes, which you see commonly in CTF challenges. And we can see it's all zeros right here, which probably means that they just modified the first couple of bits and then the rest is a valid PNG image. So for this, you can just generate some random PNG file. So I just take a screenshot real quick, move it here. We'll open up this PNG, oops, and close this one. So this is a real PNG and this is a fake PNG. And we can see there's the IHDRs that match up, and then there's 000D, 000D. So it looks like it's just these bytes that are messed up. So we'll copy those over, place them here, and then we'll save that challenge file. So then we can do open challenge, and it opens. So we're given some weird sort of cipher characters. Whenever you encounter these, there's a really good website. It's right here. Decode.fr symbol ciphers. This thing's amazing. It just has the images for a whole bunch of different ciphers. And so you just kind of go through and look at what they look like. So we can see a bunch of straight lines, and then there's characters on the bottom and the top. So we look for one that has a bunch of characters like that, I think, and this one looks pretty close. So we can go check it out. And yeah, this looks like what we need. If you read up on this one, you convert these to numbers, these Cistercian monk numerals. And so you look for a conversion chart. Is this one? Yeah, this will work. And so the way to read these specific numbers is these images or these symbols are additive. So if you want to do 11, you combine these two things. So this is 1 through 10. Then we got 10, 20, 30, 40, 50, 60, 70, all the way to 90, and then 100, 200, 300. So if you wanted like 123, you take this symbol, you can add this little dash to the side here, and then you would add this little downward dash here. And so to decode it, basically you just kind of manually go through and write down all the numbers. And so I just had the decode open on one side and this open on the other side, and I went through it just number by number and added them up. I made a mistake at first, so then I grouped them up and started going through character by character. And then once I had them, I just put in a little Python script because you need to convert them all to characters. You could also do it with CyberChef or something. And you do Python 3 solve.py, and you get out the flag. And it's just old monk. The second crypto challenge is crypto 1. It says encodes the flag in ICTF. We're given a challenge file and a result file. If we look at the challenge file, it's going to have a flag. It's redacted. The flag is 15 characters long. We're given some sort of function. It looks like an encryption function. It's going to generate a result by iterating character by character, calling this encryption function with the flag, and then saving the result. And the result flag or file is just some weird output. Cool. So pretty simple challenge. It's just encrypting character by character in this algorithm. So we could try to reverse it. We could load it into Z3. Now there's a bunch of little things we could do, but we're lazy, so what we're going to do is just brute force it character by character. Doesn't require too much thinking. So we're just going to import string. Then we're going to do ciphertext is equal to open result. We're going to read binary. Then we're going to read. We'll decode. So now we have our ciphertext here. Then we're just going to do a for loop. Let's say flag is equal to this. We'll say while length of flag is less than 15. I is equal to length of the flag. For printable, let's say guess in string.printable. Like I said, we're just going to brute force character by character, or we're going to try every single character possibility that can go through this, and we'll see which one matches with the ciphertext. So then we'll say if and this is going to return a integer. So we'll say if the ord of the ciphertext is equal to the func, and it takes in first the flag, so our guess, and an index. If these are equal, we'll do a flag.append guess, and guess should be a character. And then when we're all done, we'll print out flag, and to make it easy, we'll also do a join flag. Cool, and that should be it. So Python 3 solve.py, and that was it. We'll copy this over, and you just wrap that in an ICTF, and that was the flag. So not too bad. This challenge could have been a lot harder if some of the input depended on other inputs or something like that. But thankfully it's just character by character, so you can iterate each character 256 times and eventually you'll find the correct one. The first reverse challenge was Meow. There's no description, just a download file that says Meow. So I already have it downloaded. We can run it. It doesn't do anything. We can run strace on it. Doesn't look like it's doing anything. We can run strings on it. And doesn't look like anything. So at this point I loaded it into Ghidra. Oops. There's a main function which all it does is return 0. So at this point I did look at strings here, even though we already looked at strings elsewhere, but just to make sure I wasn't missing anything, because usually for the first reversing challenge there's something like that. Then I started scrolling around, and if you just scroll a little bit lower you'll see this data section and it has ICTF here. So it was strings, but there's just a null byte in between. So we could copy this out character by character, or we could write a little solve script, solve.py. And so what we're going to do is open, it was called Meow, oops, open Meow, we're going to read binary, we're going to read, and then we want to print, oops, data is equal to, and then we want to grab by bytes of 2. We want to decode, because it'll be in bytes. There probably will be errors, and we'll just ignore those. And yeah, let's see what we get. Python 3 solve.py ICTF. I don't see an ICTF, so we might have been at the wrong offset. So we'll start with a 1. And there it is, ICTF. Easiest challenge of them all. The next challenge is RevThis. It was a reversing challenge, there's no description, and we're given a download file. So we can see what type of file it is. It is a ELF 64-bit, not stripped. Let's run it. RevThis. We're given a bunch of output. Maybe we can do word count. So it's 33 characters of output. It's interesting. Let's do an strace on RevThis. Doesn't seem to be doing anything too exciting. There's a call to get random, but that could be just part of normal execution. We can try passing some input, see if anything changes. Doesn't look like anything's changing. So at this point I moved to Ghidra. Here is the main function. Reversing is definitely not my strongest category. So whenever I can get an easy win, I always just take the easy win. And so when I first approached this challenge, I saw it's doing a bunch of math. There's 3 main functions. Looks all very mathy. So if I could, I'd send it over to angr, but it was very weird that it wasn't accepting input anywhere, which makes me think that we're supposed to change something with this binary, or the flag is located within the binary. And it's also weird that the binary was printing out stuff. But anyways, like, and especially looking at this, like this weird floating point stuff, like that's just not precise at all. I just didn't trust it. And so when I saw this message function, I thought it was interesting that, actually, let's go back to the main function. It's going to do all this weird math, then it's going to call some random strings, it's going to loop over some variables, just changing the name of them, I and j, and then eventually it's just going to call this message function once at the very end and pass a single parameter, and it kind of looks like all this code is just generating the single parameter, which is local 90, which is just some integer. And then it's calling this message function. Again, there's a bunch of hex and stuff. It's loading a bunch of values. If we look here, it's looping over stuff again. And here it looks like it's reading character by character from this long 38 structure, and it's not using the rest. So I think that this is just being misrepresented, and this is actually probably not just an integer, but it's actually probably some sort of char array. I forget what its size is, but we'll just set it to char 30. And so it's just going to loop over character by character and XOR bar input. And so at this point, I was wondering if maybe we're just supposed to change this input, like maybe all that randomness is just not working correctly, and if we knew the correct offset into this function, it would print out the flag correctly, because putchar is just a standard library function. These hex values look static. The only thing that's really changing in this function is this parameter, and so we only have 256 values to check. So if I was in a normal CTF, I would probably just copy this quickly, take it over to Python. Actually, I'd probably just take this code and go to CyberChef. Instead, I decided it'd be fun to learn a new tool, and that new tool is GDB scripts. So my teammate wrote one of these in a previous CTF challenge. Actually, it was LA CTF, a challenge called Switcheroo. And it just seems like something that would be super useful to know and be able to just do on the spot. Because I imagine GDB works pretty much everywhere, and you know GDB is going to work correctly. Like I love angr, but it doesn't. There's probably some sort of instructions, like some weird floating point instruction, it just doesn't quite do correctly. Whereas you can always trust GDB to probably do the correct thing, just because GDB is just so prevalent. And so if you know how to write quick GDB scripts, like that just sounds beautiful. So I wrote my first GDB script. Really wasn't too bad. There was one trickery with stack frames, which I'll talk about in a second, but otherwise, pretty much you just use this Python wrapper to just pass it GDB commands, and you can jump all over the binary. Normally you can't do this import GDB within Python. Like it's not a library, but if you execute it within GDB, so you do GDB/x and then the Python file, because GDB in Python there's like some type binding, then you're able to do this import GDB. So I do gdb.export. Again, these are just normal GDB commands. So we're going to load the file, RevThis. We're going to break on main. We're going to break at the very end of the message function, so ox9a, and that's just the end of the function. We're going to start it. So unfortunately, within like newer versions of libc, everything has to be stack aligned. It just means like the RSP register has to end in a 0. And the way this works, sometimes the stack was being unaligned, and so I just reset RSP to a good value at the start of every loop. And then, like I said, what I'm going to do is I'm going to jump to the start of message, and for each character, I'm just going to see what happens when you call message with that character. And so I'm doing a set RIP, I reset the register in RBP, again, just that stack alignment issue, and then I set RDI. RDIs are input, so we're conforming to this, it's called an ABI, Application Binary Interface, and in this form, RDIs are input. And so we're setting that to the different values, and then we're doing gdb.execute, so this will continue until the end of the function, and then I'll grab the output and print it. This gdb.execute, I think this is how it's supposed to work. You're just supposed to do a two-string true. It didn't quite work that way. I still get the output, but it was solve. You'll see, maybe you'll see. Yeah, it prints through everything, but it doesn't always give me the output. It comes out in chunks, so I'm guessing it's being buffered somewhere. Don't really quite know what to do about that, but and then I search for ICTF, and there it was. So I don't know which input, one of these numbers generated this output, but I'm not really sure which one. It says ICTF, this is slightly harder rev task. And so there was the flag. Like I said, it'd probably be better just to do this in Python or CyberChef and just do the manual XOR yourself, but it was fun to write a GDB script. And if you ever need to write one, like here's a very simple one. This is just how they look. Basically just do gdb execute, pass in your command, and you can jump all over the place. There's also a jump command. I think the jump continues execution right when you get there. And I didn't quite want that. I wanted to set up some other stuff, so it was easy just to do a set RIP register. But yeah, it was a handy tool to know. The final reversing challenge is AnotherRev. There's no description, and we're given a download file. So we can run it, pass it some input, and it says not flag. We can say ICTF, and we also get a not flag. At this point, I went over to Ghidra, took a look. Here's the main function. It's going to read OX2 bytes into a flag variable. It's then going to call this function. If the function returns 0, it says not flag. If the function returns something else, it says flag. Let's take a look at this function. We're given a bunch of math. It's going to do a bunch of checks. So it's going to read different indexes into the flag variable. And if they equal a specific value, it's going to increment this counter. And after a whole bunch of checks, if the counter is equal to OX2A, then it'll return true, which will be 1, which will say it is the flag. So we need 20 or OX2A of these checks to pass. Thankfully, there are OX2A of these checks. If there was an extra one, that would be a lot trickier, or not a lot trickier, but definitely a little bit trickier. But thankfully, it just means we need all of these checks to pass. So this is a perfect target for Z3 or angr. I think I tried it in angr, but it was a little bit too slow. So I had to move it over to Z3. Moving to Z3 was pretty easy. Basically, just you copy this, and then you can do a bunch of finds and replace. So like if you do this one, that'll eventually turn into a solver.add.if statement, the start of the if. So you just do a global find and replace on, I forget what it was like, if, you know, this, whatever. And then you can just replace that with solver.add. And I think I had this solve script within like 2 minutes or something like that. Or all the conditions set within like 2 minutes. And then you just do import Z3. If you're new to Z3, I guess I should explain that. So it is a theorem prover, and basically it's just like this math engine that you give it a bunch of statements you need to be true or false or inequalities, and it'll figure out it'll just solve the equations for you. And so here we're creating some sort of like symbolic input. We're saying there's some flag variable. It's an array. Well, actually, we're not being correct. We're saying we're generating 42 integers and we're putting them into an array. But we're telling Z3 that there's a whole bunch of different integers. We know behind the hood that each one of these integers actually is a character for the flag. We could restrict them since they're characters to 0 to 256, but thankfully the program's pretty fast, so we don't need to do that. So we have this symbolic flag function, and we say, flag, the 40th index of the flag plus the 25th index of the flag is equal to 0x60. So we just give these all to Z3, and at the very end, we ask Z3, we do is solver.check, and so basically we're just asking if it has enough information to solve it. It says yes, it says satisfiable, and then we load the model, and then we ask the model for each one of those flag characters. We do an as long just because it's a Z3 object. If you do as long, it turns into a Python object. We convert that to a character, and then we print it out. It runs pretty fast. Python 3 solve 2.py. And just like that, we have the flag. So yeah, Z3, amazing tool, solves a whole bunch of challenges. The first pwn challenge was babyFlow. No description, we're given a netcat port and a download file. If we look at the file babyFlow, it's a 32-bit, which is interesting, not stripped elf binary. So let's take a look in Ubuntu. babyFlow, can you pass me? Let's just give it a whole bunch of A's. And we get a seg vault. It's exciting. And if we just give it a couple of A's, it doesn't say anything. So let's take a look in Ghidra. Here's the main function. We're given a 80-byte variable. It's going to do some weird local assignment. Puts, can you pass me? We're going to gets. So we have a dangerous function here with a obvious buffer overflow. We'll call this the input buffer. Then it's going to take this input buffer, pass it to vulnerable function. And then, so we have two vulnerable functions. It's then going to do a string copy. Oops. It's going to do a string copy with that 80-byte buffer into this 16-byte buffer. So another buffer overflow, and it'll return. If we look around, we'll see we also have a win function here, get shell. So this is just a standard sort of ret to win. So a nice baby challenge to start with. So we definitely want to copy our win address, and let's take a look at the solve script. So standard pwn tool solve script. We're just going to import some stuff. I disable warnings. I shouldn't, but I do. We load the binary. Here's libc. If we need it, we don't. We're given a remote, a local. I set the context. This just makes sure that we use the correct packing size and we generate the correct assembly and such within pwn tools. I set the log level to debug so we can see everything. I run everything in tmux, so I set the terminal. And so here's that win address, so we copy and print it here. I use pwn cyclic to figure out where the offset actually occurs that we need to do our ret to win. So if you run this, we can run it like this. Let's also load GDB. Yeah. So the very first time I run it, it kind of looks like this. I do a GDB attach, I receive until the can you pass me, and I do this pwn.cyclic call. And so this will tell me where the buffer overflow occurs. So if we do tmux python 3 solve, slowly loads. We'll do a continue, and here's our buffer overflow. I need to shrink it a little bit. Can't see it. But anyways, we can see this is HA. Normally there'd be more information up here, but the terminal is too big, so I can show it on YouTube. But normally it'd be up here, and it would show that the EIP register has in GAA, I'm guessing. Yeah, it must have been GAAA. And so since it has the characters GAA in it, I can feed it here to pwn cyclic find, and I know that is the correct offset for our buffer overflow. So we'll do a p.sendLine, we'll send that many characters over, and then we'll jump to our win address, and that should be it. Python 3, oops, I went back to my Mac outside of Ubuntu. Python 3, solve.py. Oh, and we need to be in tmux. I guess we didn't need the debugger anymore. Let me comment that out while this is loading. And you can see on the right it says it's starting a new program, shell is starting, and so we can do ls and who am I and everything. And to show that this works on remote, let's close the process, let's do a remote. Python 3, ls, And we can see we're here. So the flags for this competition were loaded in home CTF. And so then we can do flag.text. Uh-oh. Oh, just flag. And there's the flag. So nice baby challenge to start us out with. The next challenge is Gainme. It was a pwn challenge. We're given a netcat port and a download file. If we take a look at the file Gainme, it's a 32-bit elf, not stripped, which is nice. Let's make Ubuntu. Let's run it. It says solve the levels to gain access to the flag. I will say hello, and that is not it. If we take a look within Ghidra, let's go back to main. It's going to create an array, and these are each functions. So it's going to create an array of functions. Go back. Then it's going to say solve the levels to gain access to the flag. So there's 4 levels. It's going to ask us the input for each level. It's going to read a %s. It's going to then load that function from the array, and then it's going to call each of those level functions with the input we give it. So if we look at the different levels, the first level is just a string compare against ICTF4. So that one's pretty easy. The second one, it looks like it's going to do some string laying and a bunch of math. So level 2. Level 3 is just going to check if the parameter is equal to -0215, some large negative number. And level 4 will check if this set of conditions is true. So we could try to do all that, but we're lazy, so we're not going to do that. Instead, we're just going to throw angr at this challenge. This seemed more like a reversing challenge than a pwn challenge. So we're just going to use an angr script. If you haven't used angr before, it's a pretty magical tool. So it's a symbolic engine. Basically, it'll kind of symbolically execute your program, and it uses this tool called Z3 under the hood to kind of create these math statements, and you can ask for certain math statements to be true. So what we're going to do is we're going to pass it a good address. So that was this one. Let's add an extra one, I think. We're going to say, hey, angr, I want you to symbolically execute this program and give it the correct input such that it gets us to this line where it prints the flag. And so that basically means just like solve all the levels for me. And so we can just run this script now that we have it. Oh, let me run it in the background and I'll talk more about the script. We create an initial state, we create a factory state, or we create a simulation manager, which this will do is there might be multiple states that you need to manage at the same time, and this will just kind of be a nice wrapper for it. And we then say, hey, I want you to explore around until you can get to this address. And when you get there, just print out what you found. And so it says it was able to find one possible path that gets us there. So we can do slm.found. We'll look at what that is. We'll add this is POSIX. Is it dump? Yeah. And dump the input that got us there. So this was the standard in that got us to that address. And we can see it has that ICTF4. It looks like the second input was this. Here is the third input. And the last input was just 8. Sweet. So now we just need to pass that to the program. I tried to just pass this buffer, this whole array to the program to see if it would just work like that. It didn't. So what I ended up doing was just writing a second solve script because we needed to pass it to remote anyways. So here's the standard pwn tools that I've used in all the challenges. Just import, ignore warnings, load the elf binary, set some context. So here I saved this to a file. I already closed the instance, but I just did open payload, write binary, and then I do write, and then I just wrote that payload there. So we have it in a file called payload. So I'm going to open that file, I'm going to read it, I'm going to split on all the null characters. There's a lot of weird null characters in here. Basically I just took all those out, and I just ignore all the null characters. And so we're left with a couple of different solutions. And then for each of the levels, I just print out what the solution was. So I'm going to print out this one, and then whatever the next one was, and the next one. And then I send those over, and I start an interactive. So if we do python3 solve.py. Oh, actually, I think we want solve2.py. We'll load. We'll send all those inputs, and here's the flag. So this seemed more like a reversing challenge than a pwn challenge, but it's always fun when we can use angr. So sweet. anyways, that is all the challenges I was able to solve. There was one more pwn challenge. I wasn't able to solve it. I am interested in the write-up, but basically it asks for a 32-bit floating point integer and it compares it against a 64-bit floating point number. Very interested to see the write-up. I wasn't able to solve it, but yeah, that was it. Overall, fun challenges. Like I said, definitely a beginner-focused CTF, but thankful for Incognito for putting it on, and I'll see everyone soon. Cheers.